right, well, welcome everyone. Thank you for making the trip down here to Austin. What do you guys think about that trailer? Good, right? All right, a show of hands. How many of you guys have a sandbox environment, or your data science team works in a sandbox environment? Show of hands. No one? That poor guy over there? A few people. Everyone else has broken out of the sandbox? How many people here have heard that term used? Okay, there we go. Right, that's more like it. And so let's think about that. What do we put in a sandbox? Right? We put children in a sandbox to keep them safe and to keep them from harming themselves and others. We put toys in the sandbox. We contain a mess, right? Sort of is inside the sandbox. But we know, of course, that data scientists are not actually children for the most part, although some children are data scientists. That's not actually a joke, right? Actually, data scientists are platypi. And the reason I say that is not because they're mostly found in Australia or that they have venomous toes, but rather because of the fact that they tend to defy classification, right? Traditional classifications, the way that businesses tend to think about how to organize folks. And so, when biologists first found these weird duck-billed mammals that lay eggs, they thought it was a hoax. They're like, wow, this is not, someone glued a bill onto a thing. Maybe glued some other stuff, but they're real, right? They're kind of weird. They're real because they're in Australia. They're venomous. But data scientists don't. I say data scientists are platypuses because they don't really fit within the traditional classifications. Businesses, they tend to think about certain silos of technology, and data scientists don't fit into any of those things. But why is that though, right? Like data scientists, if you think about this very well popularized Venn diagram from Drew Conway about the actual practice of data science, it seems innocuous enough. They are sort of a hybrid. It's a hybrid practice, and it combines these overlapping, interesting circles, none of which themselves are venomous or weird in any way, shape, or form. But to do good data science, it actually does require a delicate balance of these hybrid skills. Philip Stark actually has a really nice diagram, different version, but similar. And I like it because it brings out the fact that data science is really about insights. You have to have the subject matter expertise. If all you're doing is writing code to hack some stats, but you don't understand why the business cares about those stats, then you're not doing really good data science. But if you look at if you just have two legs of this three-legged stool, it's going to fall over. And so the point here is that data science is a hybrid endeavor. It's a hybrid practice, but there's a reason for it. And that reason is to generate new insights faster, better insights faster, and you leverage this combination, the three-legged stool. So now let's think about the way that businesses typically think about technology. And of course, we all hear the term technology silos. We're all familiar with those. We've probably lived that nightmare ourselves on a regular basis. But if you think about it from an actual operational standpoint, it makes sense, right? You've got IT, which handles computers and networking of hardware and servers and all these things. You frequently have software development teams inside IT, which build the applications. They know best practices, how to code, all these things. And then they work and they deploy these applications. They work with vendors, maybe subcontract some stuff out. Then you have the data management folks who are very, very focused on the data warehouse, on being good DBAs, making sure everything is normalized and everything is performant, optimizing all the queries. That is a very solid swim lane right there. There's no reason not to have that. And then in the analytics practice, this is usually a smaller silo, but it's a more expensive one. And in the predictive analytics space, many businesses actually, and this surprised me when I kind of made the transition into doing consulting for business analytics, many businesses, their core analytics are decades old. The software and the code that runs the stuff, the crown jewels of how a business actually thinks about risk, how it thinks about modeling the future, that stuff can be decades old, gone through generations and generations of employees. But it produces a giant amount of residual artifacts, which get emailed out to people, get loaded into Access databases, and they run VBA code, and that's kind of how the business thinks about the future and its risk. And so for many businesses, we can criticize silos all we want to, but at the end of the day, it is a fairly effective scheme for managing the operations of technology. But what happens when your needs actually overflow what the silo can contain? Or maybe stated differently, what happens if your competitors start moving faster than you because they can take advantage of innovations that are outside of what the rate of growth of your silo? And what we've seen over the last 5 to 10 years is that actually this exact thing is happening. It's not happening just one of the silos, but it's happening to all of the silos. So you think about big data blowing up the traditional SQL data warehouse. If you think about cloud computing blowing up IT, managing, having tight control over all of the servers and all the code and all the various things. And of course, if you think about AI and ML pulling everyone forward into a predictive future, all of these things are examples of this kind of hilarious picture here where the silos is like, womp, can't really do it anymore. And so when we talk about the pace of innovation accelerating, that's a real effect. We're seeing that, and we're seeing it in all three places at once, this kind of perfect storm of every single silo blowing up. And so if you think about these, these silos, as they fail to contain the innovation is still out there. People who are really trying to build solutions, trying to solve end-user problems, they're going to take whatever they can find out there. And so when you look at the regions that are outside the silos, but maybe overlapping between these different concerns, you get new emerging practice areas. So one example is between data and data management and traditional IT or software development, the rise and the emergence of cloud computing, coupled with the growing amounts of data, has led to an emerging practice area of data engineering. And if you think about between data management and traditional kind of SQL data warehouses and analytics, we've seen this the emergence of automated knowledge discovery. And again, big data, it's a real thing, right? It offers all of this latent potential for insights. And so the combination of these two things overlapping leads to some wonderful tools for automated BI and data mining as a practice and data mining tools. And then down here in the space between the IT, dev, software folks and the advanced analytics area, we see a similar but kind of different thing, because there's certainly been the emergence of massively multi-core parallel computing. That's a thing that's happened in the last 10 or 15 years. Mostly, however, it's been research environments that harness that, right? A lot of business apps don't actually take advantage of that at the scale that a national lab or a scientific research facility might. And some businesses, like banks or pharma and very research-oriented, scientifically oriented companies, they certainly recognize this problem. They've been kind of scaling into this area. And I put the emergence of OSS numerical languages up there as well, because I think that what that's done is it's unlocked the innovation potential from just the walled garden of proprietary languages, and actually allowed a global community of innovators to all pile in and really, really accelerate the pace of innovation there. So the emergence of kind of numerical computing you see as being spanning that gap. And now you might say, well, come on, numerical computing is like the oldest computing. It's been around 50 years. And that's true, but if you think about what was happening in the late 90s, 2000s, most of the world in the IT and in the software development space was thinking about moving from Web 1.0, well, they're getting on the web to start with, and then moving from Web 1.0 to 2.0, and then big data was coming around in the data side of things. But all of these numerical folks were doing something very different, right? Python at that time was busy trying to build a replacement for MATLAB. It wasn't really thinking about big data as a thing. And so then what happened was they started thinking about big data, and they started thinking about scale out, and they started realizing, oh, you know what? In order to actually compete with MATLAB, we've got to have parallelization. We have to have really fast math and statistical routines. We have to have sophisticated data visualization, right? We need efficient data formats, et cetera, et cetera. And all these things sort of pulled the Python world kind of into growing the SciPy community and ecosystem. And then in the as big data, machine learning pulled on this even more into tabular data formats, into business data kinds of use cases, this led to the creation of libraries that we tend to think of as the PyData ecosystem. And that's, obviously that builds on SciPy. I think most people hopefully know that. But it certainly is a different set of use cases and a somewhat different set of configurations of the libraries. So in the early 2010s, I guess is the term now, in the early 2010s, 20-teens, Wes McKinney created pandas, and then we had tools like scikit-learn, visualization tools like Seaborn coming out that really pushed Python forward for data science as an endeavor. And we saw Python really enter center stage for business analytics. So this drawn upwards then created this open data science. Now, R was already there for many things, but R was also undergoing its own transitions. But the point is that these gaps between silos are what has led to the emergence of different kinds of practices, and data science really sits squarely in the center of all of these things. And of course, Python is the fastest growing language for data science, as Scott pointed out. So that's very cool. You can actually see this evolution presented a little bit differently in Jake Vanderplas's slides. He gave a talk called PyData 101. And you know, it's funny because I lived through basically all these years, right? And I think it actually captures the zeitgeist pretty well. Like in the 1990s, it was like, hey, we should use Python because like Perl is unreadable. It's writable, it's write-only code. In the 2000s, it was like, man, this is so much better than MATLAB. And then in 2010, it's like, man, I don't like R, I just want to write Python. And so this sort of definitely emerged in that sense. But you know, actually, this slight addition I make to that slide for Jake's. Jake doesn't think about SAS, and you know, more power to him. He's an astrophysicist, right? So, or astronomer. Anyway, the point, despite all this, despite this slide, we're not really trying to fight a language war. And I remember when we first started Anaconda/Continuum Analytics, everyone was super excited that a Python data science company was coming out, and everyone was constantly trying to troll us into hating on R, or you know, like beating up on other things. And we don't really want to get into that because actually something that's held true for Python throughout all these years, and I hope will continue to be true for Python, is that it is a really good glue language, right? Python is a yes and sort of technology. And so early on, you know, those flame wars, I think that's all settled down now. Hadley Wickham and I have very civilized, you know, iced tea at Strata. And so here at Anaconda, we definitely want to build bridges, right? And that's in the open source tooling as well as in our enterprise offerings. So it's always a yes and kind of approach for us. And that's one of the reasons why we've stepped up our game in terms of supporting R. We've added Microsoft's R Open as the default R inside Anaconda. And as Scott talked about, in the years to come, we will continue building more and more capability for R users. And at the same time, we've also built a bridge to a related, we've built a bridge to another important but different ecosystem, and that is the SQL database. So working with Microsoft, we've now embedded Anaconda as a runtime inside the machine learning services in SQL Server 2017. So if you know, next time you talk to a Microsoft rep, ask them about that. Say, hey, I use machine learning, I want to use Anaconda and SQL Server, talk to me, what can I do? You can come talk to us as well. The Microsoft rep is mostly going to try to talk to you about Azure, so you have to really actually, you know, kind of broach the subject about Anaconda. And of course, Anaconda's in Azure as well, so you know, it's all good. But anyway, please definitely come talk to us about that. So you know, Scott showed this graph again. It's a nice graph, that's why I'm showing it. But this terrific kind of expansion and growth over the last 5 or 6 years, that's the result of the work of a lot of, you know, hard work by many, many people. How many Anaconda team folks are here? Raise show of hands. Yeah, let's give them a round of applause here. It has been a really, really tireless effort. And you know, something I was just thinking about the other day as I was listening to music in my car was that actually, if you have 2 million downloads a month, that's basically going double platinum every month. All right, I'm just going to put that out there. But anyway, so this is great. It's the result of a lot of hard work, but it also, like, I look back and I think about the journey thus far, and I can't help but feel like we've been extremely lucky. We've been very, very lucky. And so how many of you have heard of the concept of a post-turtle? You recognize this? A few people? I don't know. It's an obscure cultural reference, but I'm a student of the human condition, so here we go. So the idea of a post-turtle is that, you know, if you're driving down some country road and you see a turtle on a fence post, and you might wonder, well, who put him here? Because he certainly didn't get there by himself, right? He doesn't really belong there. He really can't get anything done while he's up there. And generally, people use the term post-turtle to refer to politicians. There's one particular politician from Texas that I think of that was called a post-turtle. And actually, other people turn this around a little bit, make it less political, and they use it as an allegory for evidence of the existence of God. So if you go down the country road and you see a turtle on a fence post, that's God telling you, hey, you know, I'm trying to get your attention. So Anaconda's success at this point, I feel like, makes us a bit of a post-turtle, right? Because the things that have guided the development of tools in the Python data science space, they're really rooted in this disruptive moment that started 5, 6, 7 years ago in the shadow of the big data wave that kind of washed up on business data warehouses and whatnot. And of course, this will continue. I mean, this space, this gap is not going to get filled in instantly, but as a turtle on a fence post, I kind of wonder how I got here, right? When I sort of look around at our community, it's been great, a lot of hard work, but regardless of whether we are a bunch of open source hackers that just got really lucky, or whether we are God's chosen turtles, we are different from turtles in that we can ask about what the future might look like for us, right? So if you're a Python on a fence post, you do have options. You can bask in the sun, enjoy the warmth, survey the landscape, and then decide where you're going to go next. You're not quite a turtle. And so what comes next, right? Where are we going? If we look at this configuration of the silos and the space, kind of the gap that data science currently sits in, there are clear gaps between data science and each of these major silos. So if you look at the gap between data science and traditional data management, that's really driving innovation and driving the development of data virtualization tools. So Dremio, one of our sponsors, are here. They're they're an example of people kind of filling that void and trying to step into that gap. In the data science and analytics or advanced analytics, predictive analytics space, that gap, there's not a single tool, but there are many things trying to fill that gap. Some people, BI tools, BI vendors, they're trying to back their way into that space by adding more machine learning into the point-and-click interfaces. Of course, people like our studio and ourselves, we're trying to build tools from the data science forward, from the data science center forward. But that gap, it remains to be seen how we actually fill that gap. And then, of course, on the IT side, as Scott talked about, our enterprise offering really bridges, it's targeted towards bridging the gaps and concerns there, right? Squarely targeting that space between data science and IT. So these gaps are real. People are actively working to vent solutions and products into these gaps. But if we go back to my first slide with the children in the sandbox, I don't think data scientists are children. I don't think they belong in a sandbox. But actually, the fact that they're trapped in a sandbox is maybe understandable, because the things they're doing and the kinds of problems they're solving, the tools they're choosing, they're really moving at a speed faster than businesses know how to manage. And so from a business organization perspective, the data scientist might be in the sandbox, but the data science team as a concept, as an independent area of practice, that is actually, I would say, more like a baby still in the womb. And so you can imagine these children playing in the sandbox. Maybe they're in the kiddie pool splashing around and trying to figure out which swim lane they go into. Based on all my conversations with higher level executives, people who are thinking about their data science investments and how they organize their teams, it's definitely an open question of where that baby goes once it leaves the womb, right? Where this little group of kids go once they actually go into a swim lane. Do we create a new swim lane for them? Where does the baby go? Maybe it's Solomon's baby, right? Maybe it doesn't actually go anywhere by itself, and instead data science gets split up, right? Like Solomon's baby. And so, this hand was coding, so it goes to IT. This hand was point and clicking and using Tableau, so it goes over into business analytics, and then the legs are sort of chubby, they go into big data. There's a stuffed elephant, so it gets thrown in the data lake. There's many ways to do this, but I think that data science in the long run actually has something very unique to offer to the business, something very, very unique to say. And that really is that it puts exploratory, yeah, pseudo bash, right? All day long. So data science puts, oh my gosh, okay. Data science puts exploratory data analytics front and center, right? That's something that's very different and unique about data science. There's a reason why when you talk to data scientists and you put them in front of point-and-click tools that are just there to generate reports, they're like, well, that's nice, but that's not really data science. It's because simply doing reporting analytics is not the same as actually doing exploratory analytics. And so I try to put a Tukey reference in every single, like Seinfeld, I think, had a Superman in every episode. I try to put a bit of Tukey in every talk I do. And so, the promise, the practice of exploratory data analysis was conceived, in the 60s, and we're only now starting to get to the point where we see that actually doing agile data exploration is critically important. We can't just go and spend 3 years doing data migrations and application build-outs when we discovered something, last week. We need it actually operationalized 2 weeks from now. And so another way to think about this is, with those silos and those circles and the gaps and everything, IT and dev and data management and predictive analytics or business analytics, they actually inhabit a plane of technology. They're really all technologies, right? And they're primarily concerned with the question of how, right? How do I write some code? How do I manage data, keep it secure, keep in compliance with regulatory requirements? How do I go and generate this report or run this VLOOKUP? But if we ask ourselves, if we take ourselves out of this flat land and we look at this, the question of why usually rests with the business stakeholder, and we let it rest with the business stakeholder. We assume they know why they're driving technical requirements on us, right? They sort of float in the clouds like Greek gods, and they rain down requirements and rain down budget, and you know, the people that inhabit the mortal plane sort of run around trying to meet their needs. And my contention is that data scientists actually, because they have to understand the business domain in order to do their jobs effectively, by virtue of that, they actually sort of sit outside of that plane a little bit, right? They actually have to answer to the business stakeholders, of course, but they actually own some of that domain context themselves. So to view them as simply being another circle, you know, running around, floating around, bouncing around in this technology space, merely answering the question of how, is to really, really underserve the purpose and to miss the point. And so I think that the future world of business computing will inevitably be filled with, you know, data and clouds and data lakes, and those data lakes will rest on the backs of giant elephants. But those elephants are just infrastructure, right? Those elephants are just sitting there to keep the thing up. They ride in the back of this giant turtle, no longer a post turtle, but giant turtle flying through the space of business opportunities. And in that turtle's mind, in that turtle's heart, that's the beating heart of data science. That is that question of why, that exploratory data analytics. Kind of the passion for that puts the science in data science, right? That spirit of innovation is what data science has to hold alive. And as Python, so right now we're looking at, you know, Python ending, coming to the end of, I think, the first decade as a major force in business analytics. And the data science tribe, of which I think most of you would self-identify as being a member of, the Python data science tribe really has to step up. And we have to step up from being mere technologists to you know, living in this flat land to actually becoming the backbone for structuring how businesses think about their practices, how they think about managing risk and making predictions in a world that's going to be very tumultuous, very chaotic as AI and cognitive computing start, you know, really, really showing their promise. And so over the next couple of days here at AnacondaCon, as you listen to the talks, as you talk to other Anaconda users, I just want you to be thinking about that. Within your business, within your organization, how can you help elevate the conversation about data science and predictive analytics out of this flatland of mere technology and into actually being a backbone, being a bridge, being this flying space turtle for your business. Thank you very much.